All right, guys, we are going to do a really quick video today over direct variation. Direct variation is a special type of linear relationship. So remember, think back a while ago when we studied linear relationships, y equals mx plus b. This is a special type of linear relationship in which the equation is y equals kx. So it's kind of like y equals mx plus b, except for the m is a k and there's no plus b. Specifically, the k cannot be 0, so it's going to be a number that's not 0. And the k has a special name, and it is called the constant of variation. So in y equals mx plus b, the m is the slope. Here, in a direct variation situation, the k is called the constant of variation. Okay, so let's look at a couple examples to get a better idea of what direct variation is. We are going to look at two examples here and determine whether or not the given equation is direct variation. And if it is, we're going to identify what that k value is. So look at the equation 2x plus 4y equals 0. That's standard form of a linear equation. Let's try to get it in the form y equals kx, because if it can be written in that form, it is direct variation. So I need to get my y alone. So we know to subtract 2x from each side, and I get 4y equals negative 2x. Now divide each side by 4. I'm trying to get y all by itself. I get y equals negative 2/4 over x. Well, how do we reduce negative 2/4? That would reduce to negative 1/2 x. Is this written in the form y equals kx? Well, indeed it is. The k, the constant of variation, is negative 1/2 in this situation. Let's look at the next one, and this will become more clear to you. If I try to get it in the form y equals kx, I get y alone, so I'm going to subtract x to each side. I get y equals negative x plus 7. Can that be written in the form y equals k times x? No, because I have this plus 7 part. In direct variation, you're not allowed to have anything there. Nothing can go in that plus b part. So this would not be direct variation. Therefore, there is no constant of variation. All right, let's look at two tables here. So I can tell if something is direct variation from a given set of ordered pairs. Okay, and if it is direct variation, again, we want to tell what that constant of variation is. So we know that y equals kx is our equation. So if I want to solve for what the k is to tell if there is a constant of variation in each ordered pair here, if I want to solve for k, I would divide each side by x. So my constant of variation is simply my y of the ordered pair divided by my x. So let's look at the first ordered pair, which is right here, 2, 1. The constant of variation there would be the y, which is 1, over the x, which is 2. Let's look at the next ordered pair in my table. If I search for the constant of variation in that ordered pair, y over x, 2/4, well, what does 2/4 equal? 1/2. All right, let's look at the last ordered pair, 6, 3. If I search for the constant of variation, I take y over x, so 3 over 6. What does 3/6 reduce to? 1/2. So notice that in each ordered pair, my constant of variation was the same. Therefore, this is direct variation, and my constant of variation is the 1/2. All right, let's look at the next one. My constant, I can take my equation y equals kx, just as we did in the last one, and solve for k. K equals y divided by x. So I take y divided by x, 8/6. What is 8/6 reduced to? 4/3. Okay, let's look at the next ordered pair. I have y over x, 10/8. What does that reduce to? 5/4. Ooh, that's not good. And last one, I already know it's not going to be, but let's just go ahead and do it. 12/10. What does that reduce to? 6/5. Notice that none of these constant of variations are the same. They have to be the same constant of variation in order to be direct variation. So this is not direct variation. All right, it does not fit with that equation y equals kx. All right, one last example, then we're done. The value of y varies directly with x. Okay, so they just told me in the problem this is going to be a direct variation problem because y varies directly. They tell me that when y is 8, x equals 24. So I've got an ordered pair here, 24, 8. It says find y when x equals 27. So x equals 27, they want to know what is y. All right, well, I know it's direct variation, so I know it fits with my equation y equals kx. So I can take the ordered pair that I know and solve for the constant of variation. So my y is 8, I'm searching for what k is, and I know that my x is 24. So if I divide each side by 24, I have found that my constant of variation, if I reduce that, is 1/3. All right? So now I can use that constant of variation in a new equation that I write, y equals kx. I know the y, I don't know the y, that's what we're searching for. I know the constant of variation is 1/3, and I know that my x value is in my ordered pair, 27. What is 1/3 of 27? 27 divided by 3, which is 9. So the answer to the problem that they wanted is y equals 9. That's all there is to it. Seems pretty simple. It goes right back to linear equations. It's just a special type. We'll practice this in class.